Hello everyone, welcome back to another video. Today I'll be doing calculus for grade 11 and we'll be starting with limits, on how to apply limits when we are given a calculus question. So without wasting any more time, grade 12s, let's get into this video. So let's start. We are given a limit x 0, so the limit of x is 0. So when you are given an x squared plus 3x plus 4 in the calculus section, you can enter the limit into the equation. So when you say 0 squared plus 3 times 0 plus 4, it gives us 4. So if we get a number instead of error, then we are fine. We do not have to factorize. But if it happens that we are given an equation like this, the limit is -1. So into this equation that you are given, you substitute -1 into each equation. Then with this one, you are gonna get error. So what the trick here is that your denominator should never be 0. So when the denominator is 0, it means you cannot divide by 0. So you are going to get error. So what we can do here is factorize. After cancelling what we can cancel, we have to cancel this denominator because it's 0. Factorize the top, and then you'll be able to cancel the denominator, and then after cancelling the denominator, you'll be able to substitute this limit into the equation. So remember, when you plug in the limit into the equation and it gives you a number from 1 to infinity, or even a -10, as long as it's not error, you are fine. You leave it like that. But when you get error, you have to factorize. Now I am going to show you how we will factorize this. So what we will do, so here is the equation: x squared minus 3x minus 4 over x plus 1. Now we have to factorize, find the factors of 4, which is 4 and 1. Now we are gonna say limit -1, then we will have x minus 4 and x plus 1 all over x plus 1. Then we can cancel this 2, then we'll be left with limit x -1 x plus 4. Now we can substitute. So we're going to use the limit in the next step. We do not have to write it here. So we'll just say -1 plus 4, and that will give us -5, and that will be your answer. So this is the full step. I hope you understood the step. Now let's do another question just to practice, which is this one. Sorry, I had forgotten to write x. So this is what we have at the moment. We have x squared plus 3x over x. Now what we have to do is to solve this, right? All right, so we are here. The limit is 0. So you have x to the power of 2 plus 3x over x. And then the first thing you do is to substitute 0 into this equation. So you're going to take your calculator, and then you say 0 squared plus 3 into 0 over 0, and that will give us error on the calculator. So what we have to do, it means we cannot solve this way. We have to factorize. So to factorize, I am gonna take, we have x as common, we have x squared plus 3x at the top, so we can take x outside and then add x plus 3 on the inside, and then have all that over x, right? So let's still apply the limit because we haven't used it. So this x will cancel this one and we'll be left with x plus 3. And now we'll be left with x plus 3. Now when we are at this stage, limit h 0 x plus 3. Now at this stage we can substitute the limit, so that will be 0 plus 3. We have used the limit, we don't have to write it here, and that equals to 3. So we have solved that part of the equation. So this is important information. Plug the limit in the equation, and if you get error, you have to factorize and cancel where you can. And if you don't get error, everything is fine. That's what we've just said, right? So let's move on. All right, now the second part is first principle. So firstly, we have learned how to apply the limit, which you will see we will be using towards the end, until the end. So we are doing first principle, right? And the formula for first principle is f at x plus h minus f at x all over h, with the limit here. That is the formula for f at 8. Here is not 1, it's h. So that is h, limit h 0. So the limit of h is 0. Now f at x plus h minus f at x over h. That is a formula for the first principle. If you are told to solve an equation, maybe something like this, using the first principle, this is the formula that you use. This is the formula for the first principle, right? So that simply means that where you see x, write ax plus h. So in this equation, we have f at x equals to x squared minus 3x minus 4. So you see here the x plus h, the f at x plus h, meaning wherever you see x, you're going to write x plus h. Yes, this is when you're asked to solve with the first principle. So we have used it, we don't have to use it there. So here we are. Here you said for you to get what we got here, you will say x times x, that's x squared, x times the h, that is xh, and then h times the x, that is xh, and then h times the h, and that is h squared. Then we have negative 3x. This is 3 times x. Is this negative 3 times x is negative 3x. Negative 3 times h is negative 3h. And then we have the negative 4 here. Now, what we can do here is that we combined these two h's. They are like terms, so we combine them, and then we have 2xh. That shorten the whole thing. So there are no like terms. There is absolutely nothing we can do better than that. So we are going to apply the formula that we've been given. So here is the formula, right? Limit h is limited to 0. So f at x plus h minus f at x all over h, right? So here is the short version where there are no like terms. It's x squared plus 2xh plus h squared plus 3x, and I did not write the 4 minus 4 there. So we put that into the equation. We found that this is a product of f at x plus h. So this long one is the one that we've just seen, is the product of f at x plus h. And then we do the original formula is f at x, so that is x squared minus 3x minus 4. That is the original formula. So when we are here, you subtract it like it is written for us, and that is over h. So we can't, there's nothing to substitute h with. And then when you are here, everything that does not have h has to cancel to show that you've done everything right. So x squared and this x squared will cancel. 3x and this 3x will cancel. This 4 and this 4 will cancel. The only thing that is left is this 3h, h squared, and 2xh. So everything that does not have x has been cancelled. That means you've done everything you have to do correct. Prove you have done well at the top. Everything without h must cancel. And then you will be left with this at the top, 2xh plus h squared minus 3h. You see, we're only left with h. And now when you are here, the next step is to take out the common factor, which is h. Then you'd have 2x plus h minus 3, and then the bottom h will cancel that h, and then you will be left with 2x plus h minus 3. Then you apply the limit. Wherever you see h, you say 0, and now this is 0, right? So 0 minus 3 is still negative 3. So your final answer is 2x minus 3. I hope you understood that. Now let's do another example. All right, here we have x squared plus 3x, something like we have similar used, but that was over x. So here we just have it like that. And then the first step that we have to do is just to let's write the formula. Or over h. So here we'll say f at x plus h equals to x squared plus 3x. So wherever we see x, we put in x plus h. So that will be x plus h squared plus 3 into x plus h, right?